Okay, this is section 2.2. We're looking at powers of 10 today and the zero exponent. So this builds on what we did last day with section 2.1 with learning about what a power is. So let's see if we can learn how to evaluate powers with a base of 10. So let's complete the table below. We've got words, we've got the standard form, which is really just a number. So how do I write 1000 as a number? Oh yeah, 1000. And if I asked you to do repeated multiplication, so what number multiplied by itself a whole bunch of times gives you 1000? And if you wrote down, oh I know, 10 times 10 times 10, you are correct. This is repeated multiplication, or the expanded form. And finally, let's write this as a power. That's 10 to the exponent of 3. Can you fill out the rest of this chart? 100. And how about 10? I guess that's just 10, right? There's only 1. And I guess that'd be 10 to the power of 1. And then the last one is 1. So I'm going to write down the number 1. And I'm thinking, well, how many 10s are involved with number 1? And you wrote down 0. You are correct. There are none of them. No 10s. So how do I write that as exponential form then? No 10s? I guess 10 to the power of 0. Let's do the same thing with a different base. Let's choose a number between 1 and 10, and let's complete it with exponents of 5, 4, 3, 2, 1, and a blank one underneath. I don't want to use 2, because I know we use 2 a lot, so I'm going to use 3. If you want to use a bigger number, go right ahead. But I'm going to use 3. So let's do the exponential form this time first. Let's go 3 to the power of 5. And if I write that as repeated multiplication, that's, 3 times 3 times 3 times 3 times 3. And in the standard form, you would actually use your calculator or actually try to multiply this out. 3 times 3 is 9, times 3 is 27, times 3 is 81, times 3 is 243. And I'd like you to now complete the rest of this chart. Okay, so I'm going to be quiet, and you guys try this on your own, and let's see if we match up our answers. Here we go, 3 to the power of 1, that's just 3, which is 3. Now, what do you think my next row would be? Looking for patterns here. 5, 4, 3, 2, 1. Did you say 0? So the exponential form, 3 to the power of 5, 3 to the power of 4, 3 to the power of 3, 3 to the power of 2, 3 to the power of 1, 3 to the power of, 0. No 3's at all. And what do you think the standard form would be? Notice to get from one row to the next, I'm just consistently dividing by 3. And if you want to follow that pattern, what's 3 divided by 3? 1. So 3 to the power of 0 is also 1. Okay, let's do it one more time, but this time let's choose a negative base. I'm going to now choose negative 2. Okay? And let's now rewrite these as repeated multiplication in standard form, and let's see if we can fill in our last row as well. Okay? You go for it. This is good practice. Oops, I did make a mistake for the first row. There should be 5. This one has 4. Notice that negative 2 times negative 2, that's positive 4 times negative 2 is negative 8 times negative 2 is positive 16, right? An even number of negative signs we learned last day gives you a positive standard form answer. An odd number, once again, gives you an odd one. And notice in this chart, what do you think I would fill in the last row with? 5, 4, 3, 2, 1, the exponent is 0. The exponential form, negative 2 to the power of 0. No such thing as repeated multiplication, there's no factors, and the question is, what is my standard form? What am I dividing by here? You bet. If you can say negative 2, negative 2, negative 2, negative 2. So what's my answer here going to be? Negative 2 divided by negative 2 is positive 1. So again, notice our last rows of these columns, okay? Power of 0, 1. Power of 0, 1. Power of 0, 1. So the standard form number of 1, the number 1, can be written as any power with the exponent of 0. And this is what they call the zero exponent law. It says that a power with an integer base with an exponent of 0 is always equal to 1. How do I write this in notation? Well, I'm going to use b to represent any particular base. If I raise that number to the power of 0, this is always equal to 1. As long as the base is not equal to 0. So this is the base. Okay, base that is not 0. Okay, so we just learned the zero exponent will always give you the standard form answer of 1. Let's turn the page now. Okay, time for you to evaluate example number 1. 7 to the power of 0. Remember I just told you anything to the power of 0 is 1. Yeah. How about negative 25? All to the power of 0. Yeah, that's also 1. Whoa, what's this one here? Notice the negative sign is outside, so I'm going to evaluate this part first. So 128 to the power of 0, I know what that is. It's 1. But because there's a negative sign in front, this actually becomes negative 1. Okay? So once again, that part in red is 1. The negative just stays there. It's negative 1. Now, using the zero exponent law and powers of 10, we can actually write large numbers using powers of 10. Okay, sometimes they call this, what do they do? This scientific notation, I think, in science. So we can write, for example, the number 21,953 using a place value chart to help us out. So I started with 21,000, so I see there's 10,000. What's that again? That's the number 10,000, right? So that's 10 to the power of 4. Thousands are like 1,000. So there you go. Hundreds, tens, and ones are just like this. So if I ask you to write 21,000 using 21 and then using the word 10,000s, this is like 2 times 10,000. That represents the 20 part. There's a 1 here, so 1 1,000s. And then look at the next digit, 9. There are 9 hundreds, so 9 times 100. There are 5 tens, so 5 times 10, and then 3 ones. So this is what we call the expanded form. And I'd like you to now change this to write it with powers. So the 2 stays the same, but what's 10,000 against the power? You got it, 10 to the power of 4. Notice there are 4 zeros, that's why it's 10 to the power of 4. We have 1,000, so that's 10 to the power of 3. Notice 3 zeros, so 10 to the power of 3. 9 times 100, that's 10 squared, 2 zeros. 5 times 10, there's only one of them, so power of 1. And this one, remember that 1 is just 10 to the power of 0. So that's how we can write down this number using powers. And I'd like you to try to do the same thing now with these 3 numbers, A, B, and C. Once again, I think the first one's straightforward, so I'd like you to try that on your own. Maybe we come back for part B, because I see a 0 there that's kind of funny, and then we'll do part C. Alright? But I'd like you to try this on your own right now. So stop the video or pause it, and then come back when you're done. If you were like, did I have to write down all 3 lines? No, you didn't, but I'm just trying to show you all the steps involved, and I would like some of you to try this, especially if you're not too sure what's going on. But if you can directly go to that 3rd line, you're more than welcome to do so. Okay? This was interesting. This is 2014, so 2,000. That's 2 times 1,000. Now, do we have any hundreds here? No, it's 0. So do we need to write it down? No, so just leave it. 14, that's 1 10 and 4 ones. There we go. So let's write this as 2 times 10 to the power of 3. No 100, so no 10 to the power of 2. And then Okay. Last one, you try. I'll be quiet. Here you go, 9 times 10 to the power 5. Well, 9 times 10 to the power of... Ooh, did I do 10 to the power 5 right? Just joking. How many zeros? 4 of them. So 4, and 3, and 2, and 1, and none. Cool. Now, this is using powers of 10. That's the main part of today. But what happens if I looked at other powers that are different from 10? Could you write each of these falling with a different base? So 49 is a power of 7, meaning 7, and what's the small exponent that gives you 49? Oh yeah, 7 squared. So 49 equals to 7 squared. How about 32 is a power of 2? Could you do that? So 2 times what? 2 times 2 times 2 times 2. How many 2's to give you 32? 2 times 2 is 4. 4 times 2 is 8. 8 times 2 is 16. That's 4 of them. One more. 16 times 2 is 32, so that's to the power 5. Whoa, what's this number? This is like 10 million. So, but this is nice because remember with powers of 10, just count the number of zeros, and that's your exponent. So 1, 2, 3, 4, 5, 6, 7. Done. 10 to the power 7. And 1 is a power of 8. Remember, 1 is any base to the power of... all together now? 0. Nice.